Hello and welcome to my talk, NIF, Nimony and NIM3, the future of NIM. So I will explain what these terms all mean. But first of all, NIM3. It's an active development for 2 years now, I think, about 2 years. And we will break code. Unfortunately, we don't know how much and in which form, but there are some estimates. However, relax, please see our minimal compatibility guarantee, which means it should always be feasible to write code that compiles both as NIM2 and NIM3, which is particularly important for library developers. So this is already much better than the initial interop story between Python 2 and Python 3. Okay, so why the compatibility problems? Because NIM3 is a new development. Like we have a new compiler called Nimony that targets NIM3, and we have so many innovations coming and changes to the language and to the core. So we made a clear cut and developed a new compiler. There's also a maximal compatibility guarantee, which is something in theory, possible in theory, which would be we simply compile your NIM2 code with a NIM3 compiler unmodified. In theory we will be able to do that because both NIM2 and NIM3 have the exact same syntax and parser. Okay, what is NIF? I think I talked about NIF already at the last conference. So what is NIF? NIF is a variant of S expressions without Lisp's historical baggage. We distinguish clearly between tags and other kinds of names. And tags is always what follows a parenthesis open. And these tags are keywords or built-ins, so the tools understand what they mean. Whereas in this example, arg1 and arg2 would be names that come from the input language. So if you have a variable named x in your NIM program, it will be turned into NIF as a name x as well, but it cannot clash with a tag named x because your x would never come immediately after an open parenthesis. So this has the implications that even keywords that take no arguments, such as true, false, or not a number, should be put in parentheses to make them keywords. Okay, so but NIF is not only a text format but also a binary format. So because we use it as a foundation for to precompile NIM modules, and we needed a way to look up names more effectively than having to parse the entire file and then see where the name was defined. So there is a byte-based index for allowing efficient lookups. However, it's still, even this index is encoded as text, so it's a hybrid, and you can always open these NIF files in your editor and have sincerely clear what's going on, which is great to build tooling on top of this toolchain. We also have column precise line information for every node, like for every construct in the file, which we hope will enable us to give us a really good debugging experience. And finally, one of NIF's advantages is that it produces very short code, so it takes up little disk space. For example, the system.nim file on my hard drive, as precompiled to NIF, takes up about half a megabyte, which is, I mean, this is a large module, right? But it's still very reasonable for today's standards. Okay, and Nimony is now a compiler to NIM3, where everything is NIF. We use it to store it on disk. We also have an in-memory representation of NIF to speed up the compiler. The Nimony produces C code, and even the C code is encoded as NIF for as long as we can until it finally needs to be translated into C syntax so that GCC or Clang can handle it. The precompiled modules use NIF, so we have in incremental and parallel compilations. Our compile time eval engine is based on NIF. Then we base the plugin system on top of the compile time eval engine. And then we base the macro system on top of the plugin system for we now offer the macro system for interoperability, but I think the plugin system is cleaner. So for newly written code, you should prefer plugins, not macros. So Nimony is the compiler that gives us this NIM3. So NIM3, what does change in comparison to NIM2? Nil is finally dealt with appropriately. So ref and pointer types usually default to not being able to carry a nil value. If you need nillable types, you write nil ref t as a prefix. We got sometimes with pattern matching. I think this one is the most requested features for NIM. And NIM3 has it. We will see an example of that. We have concepts on top of generics. So the idea is that generic code should be type checked at definition and instantiation time, whereas in NIM2 it's only checked when you instantiate the generic. We got borrow checking for iterator invalidation to close the final safety hole that NIM2 had since its inception. Yes, this is inspired by Rust, but it works very differently, and it's a very lean mechanism which won't annoy you too much. We changed how the effect system works, so now there is no effect system inference anymore. We simply say funcs are no side effect, procs have a side effect. There is no like, oh, I read the procs body and see it doesn't really use side effects, so I infer it to be no side effects, and then this propagates to the callers as an information. We don't do that anymore because it was bad for library development. Because what usually would happen is many ignore the effect system, rightly so, but then the compiler infers it, and when you develop a library where it used to be the case that the compiler infers for you that your code has no side effects, and then you change it to have side effects, you could break your clients, right, as a library developer. So that wasn't too good, and we changed it. Yeah, the polymorphic accessors are now a thing. I won't go into these. We got passive procs to unify parallelism and concurrency, and we got compiler plugins. And for some of these features, we will see. I will go into more detail. Okay, some types. This is the syntax. The crucial key feature here is, can you see that? Yeah, that the case, there is no discriminator anymore, no explicit one. So, and this syntax, I know it sounds, it reads a little bit strange, but this example also shows the reason for that, because I wanted a mechanism that allows me to share fields between these different sum type branches, right? So here I have a shape, And no matter what kind of shape, they always have an origin and a color. And then depending on whether it's a circle, there's a radius. If it's a rectangle, you got the width and the height, etc. And sometimes we get pattern matching. So here is how to use these. We have the proc called area. Now it should basically probably be a func, so I'll change that. And we got, like, if it's a circle, you can extract the radius field and do some computations with it. And since S always has these X and Y fields, you can access them here in the triangle branch, because these are shared fields, whereas the other fields that you declared must be part of this pattern. Okay. Passive procs are, in my opinion, way more important than sometimes. We unify async programming and threads with these passive procs, and what it does is it turns the proc, like the annotated proc, into a state machine that you can step through. But the code remains as imperative and straightforward to read as usual. So in this example, just ignore the passive annotations and you know exactly what the program does, which is it prints hello Andrew Ryan 3 times. But since these are passives, we can do more than just calling them sequentially. You can take this greet Andrew Ryan call and delay its execution. This produces a continuation, I call it as task here. And so it's basically like a callback, like you can call it later, but it doesn't, when you call it later, it doesn't run until completion. I still not run until completion because you need to step through this task until it's done. And this allows a scheduler to do something smarter with it, right? So it can decide which task has requirements that are available right now. Okay, so in this example, I don't do any of this though. I simply say I start with a continuation as task, and then I say, does it have more work to do? I advance this is this step through. And for between every step, I also produce the next state. So this program would produce hello Andrew Ryan, next state, hello Andrew Ryan, next state, and so on. Okay, and as I said, this is the foundation for event loop. So this is all of that you need. You need to annotate your procs with passive, and you need to say delete, delete. You need to say delay. This would work out for an asynchronous event loop, but we want parallelism as well. And for parallelism, you need a fork, the way to fork 2 tasks, so that you can run one on the thread pool and the other yourself, or you can run both tasks on the thread pool, something like that. So there is a different way of, say, you can do that with delay without arguments. You get the second branch then. And this mechanism, in this sense, we combine asynchronous and parallel programming. But right now the mechanisms exist and there is some form of thread pool, but there is no production server yet that uses these mechanisms. We are working on that. Okay, plugins. Plugins replace NIM's macros, as I said. They are now even more powerful, they run faster, and they are easier to understand, I hope, and easier to debug, because a plugin is just a small, usually small program that the compiler compiles to native code internally and then runs it. It feeds it input and reads out output. And the input and the output format is NIF, which is why I consider this so important that it's part of my talk title. Okay, so we have a plugin here, and it's a template. A plugin is a template that has no body, but instead it delegates all of what it does to this other dep/plugin nim file. And I can invoke a plugin just like I can invoke a template or a proc or whatever. Now the implementation of the plugin would be in a separate file, and it would import this plugin's standard library to give us an API that works with this NIF in a more convenient way. So this is I hope you can see it. This is the pipeline. So the Nimony compiler understands this is a call to a plugin. If the plugin hasn't been compiled yet, it will compile it. Then it will feed the plugin some file names, one of which describes the input file, which is a NIF snippet. And the plugin then better produces a NIF snippet as an output, otherwise the compilation would fail. And these plugins usually rewrite the NIF, and when we analyze what the typical macro needs to do, it's basically pass through much of the structure as is, but edit it in strategic places. And this idea is what is captured here, this so-called replacer. So we have a replacer, we load from the input what the plugin should work on, and then we say, oh, actually keep it all, keep this tag, keep this argument, but wrap the argument that we get, which is in this case this string here, wrap it in an echo call. Done. Okay, but so this is the simplest form of plugin. There are 4 different plugins. So this is this macro-like template plugin. There are also module plugins, which is simply you write plugin as a top-level statement into your module, and this means this very module that I wrote this plugin statement in should be passed to the plugin completely, and the plugin is then free to rewrite the full module in whatever shape it needs. So this can be useful to add more analyze passes to the compiler. For instance, we have a plugin in development that checks statically if your code produces cycles in memory. So that would mean the reference counting wouldn't be able to collect these objects, right? So there's a plugin that checks, is my code safe? Like, can it prove that no cycles can ever be created? So there's something like that. Or you could think of a plugin that uses the full module and compiles it to code that runs on a GPU, right? Not on the CPU. Okay, we can also attach a plugin to a type. And usually a good example here is the matrix type. Whenever you use the matrix type in your program, this plugin is involved and looks for operations with this type matrix. And it wants to optimize it to ensure that the code uses the minimal amount of temporary matrices because these typically take up much space in memory. So this replaces NIM's term rewriting macros. And we have import plugins. Here you can import. You can annotate the import with a plugin annotation. And the idea is that this plugin receives this path/foo, and this could be in a different language, like for instance, this could be a C file, and the plugin translates the C file on the fly to NIM's syntax, or rather into NIF, because that is what plugins should produce. So this is really a great way to ensure interoperability between different programming languages. Or you could also say, import this module, and the plugin is actually the NIM2 compiler. So I want to use the NIM2 compiler to compile this code into a format that is compatible with Nimony. So something like that is also in development, but of course it's not clear when this all will be production ready. Okay, so now about the state of Nimony. It can compile itself on all the major operating systems. It's about 40,000 lines of code that can compile itself. So Nimony is split up into different tools, and there are some tools that do not compile as Nimony code yet, but the majority of the work can compile itself. So we have the existence proof here that it's possible to write NIM3 code, or to write code that compiles both as NIM2 and NIM3. Because that's exactly what Nimony is. You can use NIM2 to compile the Nimony compiler, and the Nimony compiler supports NIM3 as far as NIM3 exists. So Nimony itself is written in the style that works with the future. And its secret is that we have implemented a feature that allows us to enable or disable different parts of the language. For example, lenient nils turns off the strict nil checking that Nimony usually does, so that it behaves like NIM2, and likewise untyped brings back the more quirky untyped generics of NIM2, where only the instantiation is checked and not the definition. So, and we have many of these features. Here is a list, but the most important one is this last guy here. You can simply say feature v2, and it enables everything that is required to for better interoperability with NIM2 code. Right now, every single feature listed here exists for NIM2 interoperability, but in the future there will also be experimental features or maybe features that we chose should be opt-in, but the idea is I chose a very neutral term feature, because whether it's deprecated or upcoming should be in the documentation of the language. So in other words, when we decide whatever feature should be deprecated, we will do that simply by stating it in the documentation that it's deprecated. And since you opted into the feature explicitly in your code, nothing else changes. You must then be aware that the feature is not recommended anymore. Of course, you can think of tools support for that can simply go through your code base and flag this feature has been deprecated, don't avoid it. But I don't want to burden developers with this too much, to be honest. Okay. So Nimony is a working compiler. It can compile itself. It has a standard library and it's growing. We got most of the standard library is taken from NIM2. Sometimes we innovate and give you new APIs, but most of the time the APIs should be compatible with NIM2, except for when they don't exist yet, because we focus on the compiler and we often only port to the standard library that is useful for us for bootstrapping purposes. When you watch this, maybe release 0.4 has been released already, but I don't know. It should be soon. The 0.4 release marks the step in its development where we consider Nimony to be very useful for application development, for greenfield projects, right? If you start from scratch, if you have no new code and you don't care about backwards compatibility, you should be able to use this version then. But release version 1.0 is supposed to be much, much better with backwards compatibility to NIM2 code. So, however, my biggest problem right now is whenever I throw a new program at the Nimony compiler, it says something weird, it crashes, it produces strange results. So whenever I do that, I need to patch my compiler. Sorry. Please help out. Yeah, submit pull requests to nimlang/Nimony. In my opinion, the code base is very clean and it's easy to get into and submit a patch and to understand how the pipeline is set up. Yeah, well, we'll see. Okay, so this is the last talk of the conference. I thank everybody who was involved in planning it and making it a reality. This time I wasn't much involved in the organizational aspects, and I will now be online and ready for your questions. Thank you.